everyone. Welcome to our talk on declarative clients in Spring. My name is Olga Maciaszek-Sharma, and I'm a software engineer with the Spring Cloud team, and I work on all of these projects in bits and pieces.
Hello, my name is Rossen. I work on the Spring Framework team and also Spring. I've been involved in lots of things to do with web, Spring MVC, web plugs, the WebSocket, web messaging, RSocket, and now GraphQL.
What is a declarative client? Let's first take a look at a simple scenario. Let's say we have two services, the customer service, where we want to register customers, and then a verification service, where we will be asking if the customer is okay or if the customer is a fraud. So to achieve this, we will be sending HTTP posts at verify endpoint, and we will be getting some kind of customer verification result. There are obviously various ways in which we could potentially intend it. So the first way, probably not the best, is to have some method in our service class and just use the REST template, set whatever we need, so configure the REST template, add any custom headers that we might want, and run our request. However, the issue is, first of all, many of you might think it's not a very clean solution. Secondly, let's imagine this service is communicating with various other services, so we would start doing all of these in some methods. Our class would become very messy. We would not be able to reuse it. It's not the best. So what we could do to encapsulate it better, to have known parameters, to reuse code, is to introduce some kind of interface. And just have all the methods that we will be using for our service communication in the interface, and then add implementations. Obviously, with this kind of approach, we can have various implementations, so we can use a different client for some reason if we choose to, depending, let's say, on a profile. And then, of course, it is much cleaner. We can set the REST template properly for a specific client, and then it also will allow us to have helper methods. So while communicating with one other application, very often we will have things that will repeat. We will be adding similar headers, let's say, or we'll be doing some other configuration that will be repeatable. So that's a nicer solution. And we can then obviously call it in our service class. We will see this in a demo, and then we get some result, and we can do whatever else we were doing. It is already looking better than the first option. And what if we could just create an annotated interface and have a library or the framework translate it all into actual HTTP client requests and not have to deal with any HTTP client? So, as many of you know, there are already such solutions where we just create the interface, we annotate the interface to indicate the various elements of the HTTP request, and then underneath a proxy is created, and our interface method calls get translated into actual HTTP calls. Feign is one of such solutions. So Feign allows you to add annotations such as request line, where you can specify your method and your path. You can add parameters, and this is what a Feign interface looks like. And Feign actually used to live in Spring Cloud Netflix, but then the core module was removed and passed over to the community. Feign supports various HTTP clients, including Apache HTTP, HC5, OK HTTP, and also Feign has the concept of contracts. Contracts allow to support custom annotations and custom argument resolution, which is what we are using in Spring Cloud OpenFeign to allow you to use Spring MVC annotations on Feign clients. It also does support a broad range of encoders and decoders, including JSON and JSON, and metrics with micrometer support. And Spring Cloud has taken this project and provided a range of integrations for it. So first of all, we integrate with Spring MVC, and you can take your usual server-side controller annotations, such as request mapping, and all the annotations, such as request body, and use them with the Feign client. We already create auto-configuration, so you get all your Feign-specific beans. You don't need to set them up. And then under the hood, we provide the seamless load balancing support, circuit breaker support, and tracing support. And yeah, as I've said, you are now using Spring MVC annotations, so this is looking different from the previous just Feign annotated interface. And also you get the Feign client annotation, where you can pass your service ID, and this will be enough to configure all the beans for you, and also to configure load balancing for you. And this service ID will be used to resolve the host and load balance to the best instance. And obviously, when we use it, it looks similar to what we had before. It is pretty seamless and readable, but now we can pass things like header values in method arguments. We don't have to preset them. So we can see this in a project where we will have Eureka service registry running. We will have this customer service, and load balancer and sleuth will be used under the hood to provide tracing, and choosing the right instance. And we will be doing calls to the verification service. So we have these services here. This is our client. As you can see, it's very easy and straightforward. When it comes to the setup of our build, we just need to add the Spring Cloud Starter OpenFeign, Spring Cloud Starter load balancer if we want to be using any sort of load balancing, and sleuth that we are adding here for tracing information. And that's it. We also have a Eureka client, just because we will be communicating with Eureka server. And then we have a verification service. This is a simple controller, so this is the exact endpoint that we are doing this request against. And as you see, here is going to be where we are calling this method. So this sample that you will be able to access later contains all of these versions as a progression. So yeah, there is not that much to the demo. It's just a simple call, but what I want to show here is exactly that there is not much that the user has to do. You just have an interface, you annotate it, you add 3 dependencies, and you get the load balancing, you get the Eureka service discovery. So it's a service discovery server. For those of you that haven't used it, the instances will register there, and then we will retrieve them based on the service IDs. So we can configure the service ID in resources just by using Spring application name. And that's what the application is doing. Now let's see what else we can. One more thing I wanted to show you is that as we have added sleuth, we are also getting already trace IDs and span IDs on both sides, so in the client application and in the server application, without us as users doing much more than what I've just shown. So this is an integration that has been with us for quite a long time. It is very popular, so it has many GitHub stars, a lot of Maven downloads. This is just the number for 2021. And it has been very popular over the years because it has a nearly flat learning curve for Spring MVC users. So basically, people can just take their controller and copy-paste the method declarations and just tweak some things, and it works as a client. However, this has caused many issues over the time. Specifically, people trying to reuse Feign interface clients as controllers and annotating the classes the clients with request mapping. We have always discouraged it. However, users still wanted to do this. And at the end, we ended up removing this possibility after we got a CVE that was related to this use case. Also, Feign is a third-party project. So whenever there was some kind of bug, sometimes it got fixed very fast, by them, but sometimes we couldn't fix issues that we had in our repositories because they required some changes in Feign. Also, we were not able to provide non-blocking support, which was a key concern for us because throughout the entire framework, we're trying to promote this way of communicating for the applications. But first, the Feign project would have to be re-architected for us to be able to support it reasonably in Spring Cloud OpenFeign. So we started kind of thinking about how we could address these problems. And we had a Spring Cloud Square incubator project that people started working on some time ago, but it was kind of lying there. And then we decided it's time to revive it because unlike Feign, the retrofit could allow us to easily put web client and use it under the hood and have this kind of interface client with web client and with non-blocking communications. So we did just that. We provided web client support for retrofit and OKHTTP. We provided Spring Cloud integrations for OKHTTP and also for retrofit and web client support. And this is available. You can go check out the Spring Cloud Square project. There are the auto configurations. There is the seamless load balancing, same as with OpenFeign. There is the tracing. And here we only support retrofit annotations to avoid these kind of problems like we had with request mapping. However, this is still an incubator project. So we now have the version 0.4.1 that was released. And we were thinking of bringing it into portfolio. We also had another project called RetroSocket. So that project is actually a similar approach, but to RSocket communication. So our colleague that you all know, probably, Josh Long, has decided that it would be nice to have something similar to Feign, but for RSocket. And this project was created. And then the team started thinking, what can we do with all these projects? How do we make our declarative client story more consistent and easy to use for everyone? And we start supporting these non-blocking scenarios. So we thought we would just make one big kind of declarative clients project, keep the OpenFeign support there, put the Square support there, and also put the RetroSocket there. And we have brought this idea up to our colleagues in other teams. And when this discussion started, it appeared that instead of providing more and more third-party integrations, we could have an in-house solution. So we could support the reactive HTTP scenario and also RSocket with interface clients within framework. And actually, there have been requests for quite some time already in framework to have an HTTP declarative or interface client. And also, it appeared that the framework team was already thinking about introducing RSocket interface client. And we would, if we do this, we would be able to remove this issue of maintenance and depending on third-party projects. And also, if you see what we've shown you before, even though there is a lot of Spring Cloud integration happening, it is mostly just added on top of these third-party components. So we thought it would be better for us to instead integrate with components that will be in Spring Framework and build around this.
Thank you, Olga. Yeah, so that's where the Spring Framework side of the story begins. Yeah, I remember that Spring Engineering meeting when this was presented by the cloud team, and us thinking that we actually have some similar plans in the Spring Framework. And I guess that's the part where a little bubble comes on top with a thought about imagining myself speaking at Spring.io on the topic. No, the truth is actually I wasn't really thinking that far ahead, but it was a topic that we couldn't ignore or couldn't look the other way. And actually the first thing to point out is that the concept of interface clients is not anything new in the Spring Framework. We've always had the remoting package in Spring Web that some of you may be familiar with. And we're actually dropping it in Spring Framework 6 because these are outdated protocols. But the concept is exactly the same. It's different protocols, but it's the same mechanism. It's where you declare an interface. You declare an interface, and that interface you can then give to a factory. The factory will give you a proxy, so you can use that as a client. But you can also implement that interface on the server side for these protocols in particular. And that interface works symmetrically for both of those things. So that mechanism has been there, and it's not anything new. Okay, so why HTTP and RSocket now? Well, you heard the beginning of the story that we were having discussions. Spring Cloud was considering what to do with its interface clients around OpenFeign, retrofit, now also trying to build one for RSocket, and thinking about creating a repository for that. But in the meantime, we have our own issue in the Spring Framework repository for the RSocket client. I guess what Josh created as an experiment, somebody came and said, you should do that in the Spring Framework. It was a suggestion that we were already considering for Spring Framework 6. So that was the beginning of, wait a minute, we should be thinking about where this really belongs. On the HTTP side, we've had this request for a very long time. You will notice this issue, maybe it's a little small there, but that date is 2014. So that's a really old issue where this was requested. It was very popular. Somebody actually created a framework around it using the request mapping annotations. But we closed the issue basically in favor of, wait for it, Spring Cloud OpenFeign. And now Spring Cloud OpenFeign is considering what to do with its clients. I mean, you know, we basically at the time didn't think it was necessary to go in that direction when somebody existed and it seemed to be taking care of the problem.
The non-blocking scenario mostly brought this over.
Things since then have changed a lot. Then the non-blocking side of things came as a necessity. And also with time, the experience with Feign and using the request mapping annotations, that's another aspect that we're going to talk about shortly. So this was basically an opportunity to revisit the whole arrangement and recognizing what we've always known, that the underlying mechanism with the interface, the proxy generation is not anything that has to do with Spring Cloud. And in fact, the way Spring Cloud plugs into with retrofit, it's using the web client underneath and it's using filters into the web client. So it's basically number one, make the mechanism work, and then number two, add Spring Cloud extensions around that. So that's totally a good fit. And this is an important point as well. There are some questions that can only be addressed in the Spring Framework. They cannot be effectively addressed outside. For example, is request mapping really the best way to do this? Or you know, explore that question and find out. You know, we know that some issues have accumulated over time. So we decided to go ahead with this. We decided that it was something that we wanted to do for Spring Framework 6, an experiment, and it actually turned out that it works out pretty nicely. And what I want to do is take you through a little bit through the thought process of how we came to where we are. And of course, we're at milestone 4, there's a milestone 5, so there's still some time to go, but enough of the HTTP interface client functionality is there to be able to talk about it here, and we'll also have an RSocket version of this as well. Okay, so the first question, really the main question is, for this HTTP interface client, what is the programming model that we want? How, if we could design it from scratch, what would we do? And we're trying to balance, I mean, obviously the request mapping annotation is the key candidate, and is something that we need to talk about and compare against, because that's what's used on the server side, that's what's known, and so you can try to be helpful, but then create something which is not exactly what it needs to be, or at the same time you can create something new, which makes it confusing to have multiple options and questions, why do we need to have both? So really, there are two goals when we think from the point of view of a HTTP interface that's kind of neutral to client versus server. One, we're focusing on defining a single request. As a client, we're going to need to make a request, and that request needs to be concrete. It cannot have any kind of wildcard. So we cannot have a URL with wildcards like we can with request mapping annotations. We also want to avoid anything which is very specifically for server-side. So this is kind of an extreme example, but you can take a request mapping annotation and you can say @request mapping instead of get mapping or post mapping, and that's totally legitimate on the server side where you're mapping requests. And you can also make the URL path be anything, including **. So now we're really catching every request that comes in. This is not a good fit for client-side use. Obviously, on the client side, we can have URI variables. So that's a kind of pattern, but the goal of that is still to end up with a concrete URL at the end. And there's going to have to be an HTTP method. I mean, we can't say any HTTP method, right? When we make a request, we need to choose which method to use. Now, request mapping annotation is actually not just the attributes of the annotation. It's also the flexible method signature. What are the things that you can put as method parameters, for example? And what we did was we went through the list of arguments which are supported for request mapping annotation and looked at each and every one carefully and thought, okay, does this apply to client-side use as well? And what we found out is that many of them do, and for the ones that do, even the Java doc reads okay. You know, if you look at it from the point of view of being used on the client side, does anything stand out as being, we might have to adjust the Java doc? And after many, many years, for the ones that you see in green, the conclusion was that they generally fit the purpose on both sides, which was encouraging. But then you have things like servlet request, servlet response, things that you can inject into a controller method, and that only makes sense on the server side because obviously there's no servlet request from a client perspective. Similar for example, model attribute, anything to do with data binding, those are things that apply to server side where you already have a request and you need to map that onto a controller method. So this is not an exhaustive list. There are other arguments, but roughly the idea is that some are server specific and then others apply perfectly well on both sides. There are a few here which we'll come back to, like request param is a little bit interesting, right? Because request parameter is kind of a servlet concept. It's either a query parameter or form data, one of those two things. But you can think of those from the client-side perspective as well. It's not mutually exclusive. Also, request attribute. On the server side, that means a servlet request attribute. So what could that possibly mean on the client side? Well, the web client, for example, supports attributes. It's not anything that goes in the HTTP request on the wire, but you can pass an attribute and that will go through the filter chain of the client until the request is executed. So for example, Spring Security uses that if you have multiple authentications, let's say, you know, Google versus LinkedIn, you're using the same client and you provide a hint through such an attribute to the Spring Security filter, which will then decide which authentication to include with a particular request. So we have uses for that on the client side as well. On the return value side, we are interested in anything to do with the actual response from an HTTP perspective on the wire. That includes the HTTP status, headers, and the body. Then there are lots of other things on the server side, like model and view. That's HTML rendering, so that's not applicable to the client. There are lots of other things like SSE emitter. That's obviously a server-side thing, and there's other similar. This is, again, not an exhaustive list. We just focus on the status, headers, and body. Okay, so what we've established out of this is that we do need a new annotation. The request mapping annotation has semantics that it brings with it which don't fit for this. You know, we can't start saying request mapping, but if you put it on an interface, don't use wildcards, or don't use these, it doesn't support these parameters. It just becomes conceptually an overload. And this new annotation is now defined in a different context. It's basically talking about defining an HTTP interface, and it's neutral to client or server. well, the main purpose really is for client proxies, but nothing prevents it from being used on the server side as well to implement this, just like a request mapping controller. And this, just to give you a sense, what are the attributes in this annotation? We have URL, clearly, HTTP method, content type, and accept header. These are the main things that you might want to specify in a request. On the request mapping, they're similar. You know, it's the path in the HTTP, well, the HTTP method, yes. And then you have consumes and produces as the two other attributes. So they kind of reverse perspective from the server side. What are you consuming and what are you producing? So very similar, but from a kind of neutral perspective. So in terms of method parameters, it's basically a good story because we're reusing what you can do with request mapping methods. But it is a subset. Not everything applies. But it's nice that it is a subset and things that you already know can be reused for this purpose as well. Just a new mapping annotation, a new method level annotation. And these are the ones that we support at the moment. I'll go through them quickly. So you can specify, obviously, the URL at the annotation. But if you want to have a dynamic URL, if you want to override the one which is statically defined on the annotation, then you can pass it in as an argument. There is an HTTP method argument. If you pass that in, again, you can override. Well, so one thing I'm not mentioning here is that we have shortcut annotations. We have a get exchange, post exchange, put exchange. But what if you want a custom HTTP method? So then you might just define the method as HTTP exchange and then pass the HTTP method if you want it to be dynamic, or you can specify it as a string on the annotation, and then if it's a custom one, it will work that way as well. So anything that's less common, you could probably pass it in as an HTTP method argument. Headers, obviously, path variables. If you have URI variables in the URL attribute, those will be expanded and encoded. Request body, you can specify an actual value, an object to be serialized, a list of objects maybe. You can pass mono, flux, anything you can imagine on web client can be passed in here as well. Request param, so this one is a little bit more interesting. If it is a GET request, or rather I should say, if it isn't a form data request, then those will be appended to the query. If it is a form data request, then they will be used to build the form data in the body of the request. So that's how that's handled, and then cookies as well. And I think there's one more now. There's a request attribute as well, which has been added just very recently, this week or last week. Okay, so for return values, again, it's the same things you would expect on the server side, more from like a REST controller response body style methods. You can return, well, let's take a look actually. This is the verification service, which is now using the new post exchange annotation. Otherwise, the request body should look familiar. Now, this is the blocking version. This is one of the nice things about the interface, is that we can choose the style that we want. So if you wanted it to be reactive, then we could do that. If you wanted to use RxJava, you could return single. It also supports streaming with Flux. If you have server-sent events or other streaming media type, or you can just return a Flux if that's what you want to consume. You can get the status, the headers, and the body by using response entity. Again, this should feel very, very familiar. You can wrap this with a mono, so you can make it asynchronous as well. So I'm not showing all the possible combinations. There's quite a variety of range of things that you can do, but yeah, have a mono of a response entity with a flux in the response body. So if you're doing a streaming response, you can make the whole thing asynchronous, then you can get the headers, and then you can get a stream for the body of the response. You can get just the headers if that's all that you want. Again, this is supported on the server side as well. Or if it's just execution you're looking after, then you can declare it as void or monovoid if you want it to be deferred and asynchronous. And if there's actually a body, it will be released, consumed and released. So that kind of simplifies all of these things that you would otherwise have to do. So how do we create one of these things? There is the HTTP service proxy factory. Again, this should feel familiar if anybody's ever looked at the remoting stuff from before. There's a proxy factory, in this case for an HTTP service. You can also imagine one for an RSocket service or maybe a GraphQL one to come. And we're going to pass it the web client. This is mainly what it's supported with right now. But you can see that this is done through an adapter. So there's actually an adapter layer between the proxy factory and the client underneath. So theoretically, you can plug in other clients as well. Right, so we pass it in like that. In fact, I should also point out that all of this lives in Spring Web, and the web client adapter is in the WebFlux module. So you will need both of them to run with WebFlux, to run with the web client, but technically they're decoupled from each other. Once you have this HTTP service proxy factory bean, that can be injected into anything. You can inject it into a controller if you want to create a client there in place. You can inject it into any component, any service, or you can create other beans. You can inject it into other configuration methods and create beans which represent clients. And I imagine by the time this is out with Spring Boot 3, we'll probably have this bean automatically declared. It's not at the moment, but again, it's still relatively early. It's still not very difficult. Even Josh Long can do it, so obviously that's not too difficult. Ah, there, a little tip. Okay, should we show actually the in the IDE?
So first of all, let's just kill this application, and I'm also going to kill the Eureka server, and let's see what will be happening. So let me run it. And this is a very similar application to the one that we've seen before. Obviously, you will be able to access the source if you are interested. It will be available and linked in our slides. So yeah, we are starting through this controller where we will just run some post commands to trigger customer registration. And same as in the previous example, we will be using a person JSON that you can see here, which is obviously very simple. And then we will enter this register method, and here we are going to call the client. So it seems like it looks virtually the same as the previous example. The only difference is that now it's a different client that we are using. So let's take a look at this. This is the actual client. So this is what Rossen has just been showing on slide. We have our post exchange, a very simple scenario, in this case, blocking, and we will be able to pass request body as. And
I can mention here that generally the same things that you can expect from request mapping annotation, like for example, you can first of all have as many methods here as you want, but you can also put it, you can put an HTTP exchange at the interface type level, and then that can have some attributes which are reused or inherited. Just same thing that you can do with request mapping. So literally request mapping, we couldn't use it as it is, but we could reuse a subset. Even you can think of HTTP exchange as a kind of subset of request mapping, both in terms of the flexible method signature, the parameters, the return values, but also in the attributes. I mean, many of the same things. It supports URL with URI variables, just not wildcards. It supports, you know, consumes versus content type, but it has to be a specific content type. It can be anything with a wildcard and so on. Yeah, so think of it just literally switching from request mapping to HTTP exchange, but everything else should feel very, very similar, minus anything service specific.
Yeah, and here we are creating this bean. So as you can see, this is the actual client, and we are just calling create client and passing the class or the interface. And same, to create the HTTP service proxy factory is very simple. You just create this bean annotated method. You need a web client instance that you can pass in the constructor of the web client adapter, and all of this.
And that's a one-time central bean that you can then use anywhere to create as many client interfaces as you want.
Exactly. And then you have the factory. You can do some settings on the factory. Here we're setting the conversion service.
Show the base URL as well there.
Yeah. And this is our base URL that we are going to use.
So typically what you'll want to do is kind of configure the web client through its builder with some things that are shared for every request. So you can set up a base URL, you can add some default headers, you can do things like that, even independent of the interface, if it makes sense.
Yeah, it's actually, you will just usually have this one interface to communicate with a certain service, then another one for a different service. So it makes sense to set up as much as you can before, and it will be easy to use. And yeah, that's all of it. When it comes to the setup, it is practically as easy as was the setting up Spring Cloud OpenFeign. And we can run the same requests. Obviously, nothing changed. It all works as before. This example has been set up without the load balancing. However, we already provide load balancing support for web client, so it will be a very easy and straightforward integration to make.
Can we see some of the logs just to make sure this isn't
sure, that I'm just
fake?
Not inventing it. Yeah, let's see some logs. Here we are. So we have our request. We have the request response body method processor logs. We can see that some decoding is taking place.
Yep. Yeah, I think you can see the web client there. Yeah, client. Okay, good. Yeah, so the only other thing at this point is that we are going to create shortly a similar one for our socket, and I don't think there will be much shared infrastructure, but it is a good exercise to create another one which is very different, just to make sure that there isn't anything that comes out of that in terms of design. But I think they're going to be pretty independent, and our socket is itself, it has an interface which can be implemented client and server side. It's a bit like WebSocket, it's symmetrical. You take the same contract and then you can make it a client, you can make it a server-side handler or a client handler. So it's already pretty well set up, and it's just 4 methods. There isn't like such a huge variety like in HTTP with headers, with body, with all kinds of things that you need to pass in. So I think that one will be quite straightforward. And that's pretty much all we wanted to cover today. Fairly straightforward, hopefully. That means that we do have some time for questions. We have some links here as well. There's already some documentation in the Spring framework around this, and you can check out Spring Cloud OpenFeign, the link to the demo code up at the top, and the Spring Cloud Square project, and then Josh Long's retro socket.
And it's
experiment.
already available in the milestones, so you can already be giving it a try.
Yes, yes. I believe there are some videos out there. Actually, we could have included some of that here as well. Any questions? How to do this? Some mic? Okay.
Okay. Thanks for the presentation. It was really good to see the initiative to bring these declarative clients lower to the Spring framework. I have one question. What's the reason that you decided to use a proxy to implement this and not something like an annotation processor or code generation for the declarative implementation? In addition to that, considering the efforts that the Spring 6 is now doing with Spring AOT, Growl Native, and all these things for fast runtime, this would make it more difficult for Spring AOT basically to have implementations for these things, I guess.
Yeah, no, that's a very, very good question. Actually, that is something that we still have to consider. I guess the use of the I mean, on some level, it's going to be unavoidable to deal with these kinds of annotations. We also have this on the server side, right, with request mapping annotations. We're not going to change Spring MVC too much. Sorry, this is really acting up.
Maybe these are working as well.
Yeah, well. Anyway, it's kind of working. So I believe that these will be handled through hints. A lot of this will be handled through hints. Part of it might come down to just having a consistent mechanism instead of creating things that are very different. But this is something that we will probably still consider as we go forward. Thanks for the question, actually. That's something that we should explicitly think, since we have an opportunity to do it differently if we want to. Yeah, if we decided that that's the best way forward. Yep.
Can we get the microphone?
Thank you very much. It looks very promising. I have a question. Do you plan also to support Kotlin coroutines?
Yes.
Quick answer.
As to how, I don't know at the moment yet, because that's kind of the reverse of what we would need to do on the server side, but I'm sure there's a way. Yeah, we would probably have to find out that it is declared as a coroutine method, and then, yeah, we'll see on the invocation side.
Yeah. Another question. This looks really interesting to generate. Have you been thinking already about generating these kinds of clients from API definitions like OpenAPI?
Yeah. So one of the nice things about having this HTTP exchange annotation is that it creates something which is kind of more strictly focused on defining an interface as opposed to handling of requests. That's why request mapping and Swagger maybe always kind of were a little bit tension there between those things. So I think having HTTP exchange actually creates gives us an interface, a way to define, and I can imagine that this can become the basis for things like that.
I think the microphone is not working.
It's not working? Can you hear in the back? Yeah, it's kind of working.
Yeah, cool, thanks. We might actually work on that ourselves, but
okay.
We might be in contact.
Sure, yeah. No, I'll be happy if you want to chat a little bit more afterwards, or you know, that we stay in contact over that. I think my mic is getting tired.
Maybe it's an out-of-scope question, and maybe it's related to what he said, but do you have any preferences on whether these interfaces should be declared on the server side of the communication or either on every client? I mean, in the server side, I guess you could have export another artifact on Maven and then having a binary coupling with each of the microservices clients, for instance.
So do you just mean for, what would you do with those on the server side?
I mean, in the server side, on the communication between microservices, everything is server side.
Yeah.
But I mean, do you have any preference on using this, like declaring it in the receiving service?
To use that as a controller on the server side, is that what you're saying?
No, I mean, you as I understood the presentation, you can declare those interfaces in each of the microservices that consume, or you can declare it on the one. Sorry, on the one. On the ones that consume, or you can declare it on the one that receives the calls, and then you could have a binary coupling.
Yeah, so that's not
reuse.
something we support at the moment, but the way that the HTTP exchange interface is being designed is to be symmetrical and neutral to client or server. So that is something that potentially can be done. It wouldn't be too challenging to adapt server-side controller. So let's say you were to implement this interface from a class and call it @controller.
Yeah, that's an option as well. But I mean, on the current implementation, would you define, if you have 3 microservices communicating to another one that has this API, would you declare this interface in the microservice that receives the calls, or on each of the clients that calls it?
It's not supported currently. It's not
I don't understand it.
For now, it's just the client proxy generation.
As a client,
Yeah.
wherever you would
then
usually use a REST template, you could instead use this. But I'm also thinking it might be interesting to see a possible integration with Spring Cloud Contract, where the contracts are being defined and kept in the server repository often. And yeah, but this is not something that we currently support.
On the server side, it raises, while it's possible, and actually technically you can see how we could very easily, just like we scan for the request mapping annotations on the server side for a controller, we could also look for the HTTP exchange annotations, and then you have a controller, just like what you have today. Because the arguments, everything is the same, it's just a subset. So that was important to be able to do that. But then it means that on the server side, you're going to have to kind of constrain yourself to those things which are supported by HTTP exchange and that also work on the client side. You cannot start adding. Sorry, maybe I should take it off. You cannot start adding, let's say, like model attribute or using wildcards. Those things would be strictly client server side. So then you would just have to switch to request mapping. So there's a bit of a, how exactly should that work? But technically it would be quite easily achievable to support HTTP exchange on the server side. We're considering it. So any kind of feedback there also would be interesting about interest and use cases. And we have a couple more minutes. Any last minute questions?
Yeah, hello from me. One question. Will there be any resilience mechanisms provided out of the box, or will it be extendable with something like resilience for J?
I imagine that we would provide an integration for this. So we just, instead of taking a third-party dependency and providing this integration such as Spring Cloud Circuit Breaker, we would provide it for this tool.
It might already work as far as I can see. You have the web client underneath, and as far as I know, Resilience for J supports that. So again, it might come down like the Spring Cloud extensions, where once you have a client underneath, and if you have things for that client, then you can use Spring Security, Spring Cloud, Resilience for J.
Thanks.
All right. Well, thank you very much. Enjoy the rest of the conference.
Thank you.